Good morning, everyone. Syllabus is still types of fission, types of organic reagents, na? Space syllabus, and they have written a space syllabus till okay, clear. So that means we have to study very less things today. Navdeep, Sanmukh, Vinaya, Yashwanti, Charan, Anuradha, Lekha. Okay, good afternoon, everyone. Okay, so we have to study only very less thing, practice the questions. We have to study electrophile and nucleophile, na? Reagents. In the last class, we have discussed about that bond fission and all. Homolysis is there, homolytic fission. They also say homopolar. Homopolar also means homolysis. Okay? So let your friends come. So I have already written few things about electrophile on the left side, and I have left the space on the right side. So right side we will see. What, writing, deleting, practicing here? Huh? Okay, fine. So let's start. Fajans rule, can you explain about polarization? We have said na Fajans rule, polarizing power and polarizability. For cations, you say polarizing power. For anions, you say polarizability. So this polarization is directly proportional to charge or oxidation state, directly proportional to size of anion, inversely proportional to size of cation. Chalo. So let's come to this point. So we have written the differences between electrophile and nucleophile, and you know the points also. So now you have to fill in the second part. So let's start. This is electron loving. Then this is what? Batao. This is nucleus loving. They also call it electron seeking. Electron loving or electron seeking. This is represented as E plus. This can be represented as Nu minus. This will act as Lewis acid. This acts as Lewis base. You know what is Lewis acid? Electron pair acceptor. Electrophiles also what? They are electron deficient and they accept a pair of electron. So you can say Lewis acids are what? Electron donor. Nucleophiles are also what? Electron donor. Okay, then you have written here that they are electron deficient. Here I will write what? They are electron rich. They have vacant orbital. If they are electron deficient, they will try to take electron. That means they should have a vacant orbital. So having vacant orbital to accommodate electron or to accept electron, you can say they are electron rich, have lone pair. They have what? Lone pair. Okay. Now you can write here examples. Like examples, they have written ki some positive species are there, some neutral species are there. Okay. Here you can say what? There will be some negative species. Here also there will be some neutral species also. So we are writing the examples. Okay, you have written Cl plus. You can write Br plus, means halogen plus. We are talking about what? Halogen plus. CS3 plus. In future you will study that thing, you remember, electrophilic substitution reaction. Then you will study there. What you will study? Batao, kya padhoge? You will study there Friedel-Crafts alkylation, acylation, nitration, sulfonation. So all these electrophiles we should know. So next electrophile you can write RCO plus. This is acylium ion. Acylium ion. This is nitronium ion, NO2 plus, halogen, and all these things are there. Chalo, theek hai. Okay, then next part, negative charge species, like you can take Cl minus, H minus, CS3 minus, all are these what? Electron rich species. They will donate electron pair. Then they are saying tell examples of some neutral nucleophile, like water is there. Water is neutral, but it is electron rich. It will give its lone pair, like you can say alcohol, you can say ether, all these things are there. You can say ammonia. Dekh lo. So these are the examples. Okay, then you will see examples in this also. Ki neutral BF3 is there, AlCl3 is there, ZnCl2 is there, FeCl3 is there. Now what happens na? Ki BF3 and AlCl3, these are to having less electrons, 6 electron only, 6 electron only. They have incomplete octet. They have incomplete octet. So that's why they take electron pair. But other things like zinc and iron, octet are complete. This is having pseudo noble gas configuration. This octet complete, you can say, already not deficient species. Then also they take electron in their vacant d orbital. Means what is the point, you know? Ki they can accept electron when octet is complete, and they can accept electron also when the octet is incomplete. Achha, these two things I have written from white color. Means what? These are very important. People will think what? This is nucleophile. Why? Because you are seeing electrons here. Can you see it? CCl2, CH2. These are carbene. These are what? Carbene. People will think, yes sir, lone pair is there. It is a Lewis base. No, no, no. This is a Lewis acid. This is an electrophile. It is having only 6 electrons. So very, very, very important. Dichlorocarbene, correct. Its name is dichlorocarbene. If you will count the electrons, 2 chlorine bonds are there. So 2 bonds, 4 electron, and 2 electrons here means 6 electrons only. So remember this. They will give you question, which of the following is an nucleophile? BF3, AlCl3, CCl2, and water. You will think, sir, CCl2 lone pair. Wrong. So keep this in mind. Clear with this point? Then they are saying here there are some polar pi bonds also. Okay, what they are saying, there are some polar pi bonds also which can act as electrophilic center. Now you will say, sir, how this is acting as electrophilic center? Array, you can think like this. This is polar pi bond. Polar how? You will say, sir, oxygen is more electronegative, carbon is less electronegative. That means this is delta plus, this is delta minus. So this site is electrophilic, whereas oxygen site is nucleophilic. That means carbonyl compound has both electrophilic site as well as nucleophilic site. Acha, can you identify this compound? ये compound दिख रहा है तुमको? So this compound is CO2. We say कि CO2 is a weak electrophile. CO2 is a weak electrophile. You will say, Hare, how electrophile? Hare, can you see this carbon? This carbon is what? Positive. So this point is electrophile. Any nucleophile will come and attack here. Acha sir, how you will talk about sigma bond? Sigma bond, array, this is delta plus, this is delta minus. So this site is electrophilic or not? Yes. Any nucleophile will come. Okay, what will happen? See here. Any nucleophile will come and it will attack on this electrophilic center. You will study this in future. Ki nucleophilic substitution reactions are there. Nucleophile will attack, Cl minus gone. So these are electrophilic sites. So one question is there in the paper. I will tell you which question they will ask you. So see the examples once. So cationic species can be electrophile. Neutral species can be also electrophile. In neutral species, complete octet also, incomplete octet also. Clear? Fine. Okay. And CO2 is a weak electrophile. Done. Dekh lo. Similarly, in nucleophilic part, you can say that they are electron-rich species. So they can be anions. They can be neutral species having lone pairs. Special attention required for carbene here. Special attention required for carbonyl. Ki carbonyl is having electrophilic part also, nucleophilic part also. This question is in gym material also. Ki which one is having electrophilic as well as nucleophilic center? No breaking? I don't think so. Is there any disturbance? You check yours correction once. So see the examples, how many we have written. If you will keep these things in mind, means done. They will ask you nothing extra than this. Clear? Check the examples. You have written here polar pi bond. Here now they will write non-polar pi bond. Here they will write what? Non-polar pi bonds. What do you mean by non-polar pi bonds? Like you will think about ethene. So this is a nucleophilic site. Who will attack on this? Electrophile. So this is a nucleophilic site. They will talk about benzene structure. You will study in coordination compound कि benzene acts as a nucleophilic substance. By pi bond it can go and connect somewhere. So these are acting as nucleophiles. Polar sigma bond we are saying like this. See, this is a sigma bond, correct. This is carbon, this is chlorine. Who is more electronegative? Who is more electronegative? Chlorine. So chlorine delta minus, carbon will be delta plus. So this delta plus is electrophilic site or not? Yes. No, all cations are not electrophile. I will tell you few examples at last. Our last what I am writing here only. Chalo. Otherwise we will forget also. No. Like they say like this. Kisi Na plus they are saying K plus. Somewhere they have taken, but somewhere they say ki these are not counted in electrophile. Now see in these two, so there is some confusion also. You see the options nicely because someone saying electrophile, someone saying not electrophile. But in this there is no problem because in nitrogen there is no space left only. No space, already 8 electron done, and nitrogen cannot expand its octet also. So this one to confirm. But this one, na, somewhere they are writing, somewhere they are not writing. So you read the options nicely. So they say that these we are not considering as electrophile. Got the point? So carbene part important, carbonyl compound important. ठीक है, done? Okay. Now let's do some question type. Like one thing is there, they will talk about SO3, you know, sulfonation. SO3, they will say like this, SO3 is an electrophile. They will ask you how. SO3 is an electrophile. They will ask you how. So you will have to say like this, ki it has d orbital. It accepts electron in d orbital. So this is the electrophile in sulfonation. Sulfonation, if you will remember, benzene reaction is there. There SO3 is an electrophile. Similarly, SO2 when you will see there is lone pair also. So it can act as electrophile as well as nucleophile. So if they will ask you, why SO2 is an electrophile, what you will say? Why SO2 is an electrophile? What you will say? SO2 is an electrophile because you can say there is vacant orbital. Why it is a nucleophile? Then you will say what? It is having lone pair. It is having what? Lone pair. Clear? S3O plus they don't consider as electrophile. 8 electrons done, na? S3O plus also, correct. They don't consider it as electrophile. NH3 plus is not there, na? NH4 plus is there. NH3 plus means so you have removed one electron. No, but see, NH4 you are saying NH4 plus can act as nucleophile. Do you have lone pair? Batao. Octet is complete, but are you having lone pair? What you will give to other? What is the basic definition of nucleophile? Ki it can give lone pair. Electron donor. Bhai kahan hai? What you will donate? NH4 plus you can think ki it will not take also and it don't have anything to donate also. Clear with this one? Clear? Then one question will come in the paper. It will come like this, which of the following has electrophilic and nucleophilic center and the options are like CS3, CO, CS3. Second option CS3, C triple bond N. Third option they will give you like suppose NH3, and fourth option they can give you like क्या देते बताओ, both 1 and 3, both 1 and 2. So what will be the correct answer बताओ तो, what will be the correct answer in this case? Understood? Okay. Complete octet is there, then you will check if it is having lone pair, it can act as nucleophile, and if it is having a vacant orbital, then it can take electron also. And vacant orbital, d orbitals, expansion of octet, this can only happen from third period onwards. Clear? So fourth is the correct one. Now people will think, Arey sir, how this will happen here? You can think, Arey, delta plus is there and delta minus is there. Any nucleophile will come, it will attack here. This bond will be shifted this side. So these type of reactions now you will study in future. These type of reactions you will study in future. Take it. Next question we can say like this. Which of the following is correctly represented? बताओ. Which of the following correctly shows the direction of electron flow? Again, what you will say? Fourth. Why third is wrong? Because here carbon is connected to metal. Metal don't take, metal give. Metal don't take, metal give. Achha, if they will ask you in this question only which is homopolar reaction, which is showing homopolar reaction, then what you will say? Which option is showing homopolar or homolysis or homolytic fission? Got the point? That's it. Ho gaya, khatam. So this is all about electrophile and nucleophile. Now you should go and practice the questions. Clear with this? That's it. So now the next topic they are talking about electronic effects. Your syllabus was till that point only. Electronic effects. Electronic effects, we are saying we can divide it into two parts. One is your temporary effect. One is your temporary effect. And the second one is what? Permanent effect. Temporary effect means what you can say? Electromeric effect, given in NCERT. Electromeric effect. Permanent effect, what you can say? 3-4 things are there, like inductive effect, mesomeric effect, resonance, hyperconjugation. So these are your permanent effects. देख लो. They also call it I effect, M effect, R effect, H effect, like these things, na? Syllabus over for the test. Clear? I think it was till that point only. तो चलो थोड़ा पढ़ लेते हैं so that the burden will be less in the next lecture. 15-20 minutes we will study, then over. ठीक है, we have studied 25 minutes now. Time is correct. 5 minutes slow. Chalo, done. So let's start from inductive effect. So first we will study the permanent effect. Later on we will say inductive. Later on we will say temporary effect. Inductive effect. They are saying few points are there based on electronegativity difference. Based on electronegativity difference. Next point, what they are saying? Ki what is inductive effect? It is polarization of sigma electron. It is polarization of sigma bond also, you can say. It is polarization of sigma bond due to En difference. You can also say it is a distance dependent effect. Distance dependent effect. This can be divided into two parts, plus I effect and minus I effect. Now what is this effect? To understand this, we'll have to make one diagram. So sigma bond is involved in this, sigma electrons are involved in this. They also say up to 3 atoms, you are saying, na? Up to 3 atoms. There is a very good question. There is a very good question in NCERT solved example. NCERT solved example. There is a very good question based on this. So we will try to do that question. Don't worry. So like suppose I have written this compound. This is butyl chloride. Now let's focus here. You will see here. This bond is polar or not? Yes. Sigma bond. So this chlorine is delta minus and this carbon is delta plus. This chlorine is attracting the shared pair of electron. So this is only known as inductive effect. This is only known as inductive effect. Now this chlorine is withdrawing electron from carbon. So this carbon will now withdraw electron from next carbon. Then it will withdraw electron from next carbon, like this. You are writing more delta means positive charge is decreasing. Means what is happening now? The atom which is closest, from there I will withdraw maximum. Then next atom less withdrawn. Then next atom least. After 3 atom nothing. So it is happening like this. So if they will mark the carbon, suppose this is A carbon, this is B carbon, this is C carbon, and they will say which is most electropositive carbon. What you will say? Which is most electropositive carbon? Then what you will say? A, correct. Acha, which electrons are involved in this? Sigma bonded electrons. Sigma bonded electrons. So they also call this as partial displacement of sigma electron. Inductive effect is also what? Partial displacement of sigma electron. Then they also say that inductive effect is taken with reference to, inductive effect is taken with respect to hydrogen. For hydrogen, they have assumed inductive effect 0. For hydrogen, they have assumed inductive effect 0. Atom, if it is more electronegative than hydrogen, then it is a minus I group. And if it is less electronegative than hydrogen, then it is a plus I group. So this is just for saying, we will not use this point. This is just for saying, we are saying ki array hydrogen I have taken as a reference, ki hydrogen electronegative inductive effect 0. Now what? Ki if any atom is there like chlorine, bromine and all, if they are more than hydrogen, so it is a minus I group. If anyone is there which is less than hydrogen, like suppose you take lithium, sodium and all, they are less electronegative than hydrogen, then they are plus I group. They are plus I group. Third point, we are saying it is distance dependent. Distance dependent means what? Which is closest, their effect will be more. And as you will move away from this chlorine, effect is becoming negligible. Effect is decreasing. So this we are saying. So you can think here also in this example which we have taken, you think like this, ki chlorine is withdrawing electron or not. So this is a minus I group. Acha, minus I group is also known as EWG. EWG means what? Electron withdrawing group. And this can be also written as ERG, or they also write EDG. But ERG is what? Electron releasing group. Electron releasing group. So plus I group, minus I group. Plus I group, minus I group. Understood the points? So generally what happens na ki alkyl group, you know, carbon. Generally carbon has very less electronegativity, 2.5. So when it will connect with any other non-metal like halogen, nitrogen, oxygen, sulfur and all. Sulfur also something, okay, similar only. Then what will happen? It will act as a plus I group. And other atoms will act as minus I group. So here this carbon is acting as a plus I group. And chlorine is acting as a minus I group. Can you suggest me कि when carbon can act as minus I? Can you tell me one example? Can you tell me one example where carbon becomes negative? Carbon is electron withdrawing. Can you tell me one point where carbon is electronegative? Carbon is electron withdrawing. With metals, we have said na कि carbon with metals only it shows dadagiri. Otherwise, everywhere तो it is like yes or no. Everywhere it is of no use, you can think, but in metals it is becoming like suppose if I am showing like this and you show the movement of electron like this, then they will say, "Arey fool, this is wrong." Then what is correct? This is correct. Delta minus, delta plus. I told you Grignard reagent, yaad hai Grignard reagent? So shift of electron will be shown like this. Acha, they will ask you basic questions of this also. He tell me the transfer of electron or shifting of electron, movement of electron. then you will say electron is moving like this. Oxygen is more electronegative, so it is a minus I group. And these all are what? sp3 carbon. sp3 carbon, they are what? Plus I group, you can say. So they will ask you, tell me the direction of shifting of electron. Displacement, partial shifting, we will not use the word, you can use also, but it's better to say partial displacement. It's better to say what? Partial displacement. Acha, you know this also na कि electronegativity is dependent on जैसे मान लो if I write any compound like this, देखो बताओ तो, now this carbon is sp hybridized and this carbon is sp3 hybridized. बताओ, this bond electrons will be moving towards which side? sp carbon, you know, they are more electronegative. They are more electronegative. Clear with this point? देख लो एक बार. बोलो भाई. They have made one graph also. Sometimes they make one graph na. No use, not in NCERT, we can ignore. चलो बताओ तो तुम बताना. This is distance, this is inductive effect, I effect. You tell me which is the correct representation of, suppose this is 1, this is 2. Which is the correct representation of inductive effect with distance? Can you tell? Which is the correct representation of inductive effect with distance? What you will say? 2 is correct. First is wrong, na? You can say like this, na? Because in 2 what is happening? Inductive effect is decreasing with distance. Correct? बताओ, इसमें बताओ direction of displacement of electron. You will say like this, yes or no? They can tell you like this also, कि suppose you are having CH2CHO. अब बताओ, what is the shifting of electron? Like this. So that means this is a minus I group. Electron withdrawing, and this is a plus I group. So forget everything ki hydrogen is a reference and all. Simple thing is there. Check En difference. Where En difference is, where electronegativity is more, move the electron towards that side. Simple. Move the electron towards that side. Simple concept. You check sp carbon, sp3. Don't think that both are carbon. This is more electronegative. This is less electronegative. Move towards more electronegative. Clear? Okay. So we will keep till this point only. Okay, na? In the next class, we will study rest of the things. So syllabus already we have done. So we'll keep till this point only. In the next class, we will study rest of the things. Syllabus is till this point only, na? Batao. The reagents were only there. Anything else was also there. Only reagents, na? Order of plus I effect, minus I effect. From there, we will start in the next class. Tautomerism, I think it is late, na? Tautomerism, it comes in middle or something, anywhere they teach. Not a big topic. Planner, according to the planner, can you see where it is tautomerism? एक बार देखने दो मेरे को भी. Tautomerism is before intermediates, means when you will finish acidic, basic strength, this all major things will finish, then there is one lecture for tautomerism. ठीक है? हाँ, means we are talking about CH3 and Mg. This bond is a covalent bond. This bond is a covalent bond. ठीक है? You will study later on कि Grignard reagent carbon magnesium bond is polar covalent bond. So this will become minus and this will become plus. Magnesium bromine bond is an ionic bond. They have written in NCERT purely ionic. ठीक है? अच्छा, what is your homework? One question only, you can find it and then you can tell me in the next class. Solved example of inductive effect. This is your homework. ठीक है ना? Solved example of inductive effect. One solved example is there. So you just find this thing. In the next class, we will write with the order, plus I order and minus I order. ठीक है? Anything else? No na? Sir, in Grignard is more electronegative. Br is more electronegative. Mg. So that is ionic bond. This you are not knowing now, but we have said now Mg and Br ionic bond. So Mg plus Br minus. Clear? Up to reagents only. Chalo, ठीक है. So thanks everyone. Bye for now. We will do in the next week now. ठीक है ना?